Hello. So yes, today I'm going to talk to you about building Swift packages with Visual Studio Code, which kind of tails on nicely from Daniel's talk and links in with a few of the other talks we've had today already. So introduction, we'll kind of speed through this. I run a company called Broken Hands. I'm part of the Vapor core team, so I'm responsible for effectively maintaining and building Vapor and growing it. I'm a workgroup member of the Swift Server workgroup and the Swift website workgroup. So the Swift Server workgroup is responsible for advocating Swift on the server. So we have really good ties with the Swift core team and the language team, and we can make sure that Swift is as good as it can possibly be on the server. The website workgroup is responsible for Swift.org, which is now open source, and our remit is to kind of make it look like a website that wasn't designed in the 90s. So there should be some changes coming over the next few months to kind of modernize it a little bit. As mentioned, I'm an author instructor at codeecho.com, which used to be raywendlick.com. I used to run the server-side Swift team there, but I've now stepped down and handed over to people who have more time than I do. And you can find me on Twitter and, well, for now, and Discord and GitHub and Slack as 0xTim, and that 0 is in the number, as if you're writing hex, which seems to confuse some people. And I organize a couple of meetups in the UK and the server-side.swift conference, which I'll talk about right at the end. So, IDEs, what are they? So IDEs are integrated development environments, and we have them to help us write code. In the very, very early days of writing code, which most people here probably won't remember, or at least have experienced, you had what were called punch cards, and these were literal pieces of cardboard that you went through and you manually punched out your code into the card, and then you had a huge stack of them, you loaded them into a computer, and it would run through your code and generate your result. And this was revolutionary compared to kind of doing maths by hand or kind of any kind of calculations by hand. It made life a lot easier. But it's not that great. It's quite error prone. If you punch the wrong hole, you've got a problem in your code. You also get bugs in your code. And these were literal bugs, as in insects that got stuck in between the punch cards as they were loaded into the computer. And that's why it's called bugs. So fun fact of the day there for you. So we've kind of moved on a little bit because that wasn't the best experience for developers. So as we kind of moved up the stack and wrote higher languages for kind of higher level stuff, we went into text editors. So this is a very simple C code running in Notepad++, which is quite a popular Notepad editor or text editor, although it doesn't offer things like code completion or any of the advanced features that we're used to. But it was a huge step up from punch cards. The more sadistic of you will use something like Vim or Emacs, but I'm going to gloss over that because that's not very good. Most of us here will be used to using Xcode. And Xcode is Apple's IDE. It's what you use for building packages and apps for Apple platforms and other platforms as well. And despite all of its flaws, because we know it has many, it is actually a really good IDE. It works for the most part. It's been built by a designer, which, you know, compared to some of the other IDEs out there, puts it well above some of those. And it has things you'd expect. It has code completion. You get syntax highlighting. You've got debuggers integrated. You've got the memory graph and all the instruments that you can spin up, which are really, really powerful. But there might be occasions where you want to use a different IDE. And there are many reasons for this. You might be working in other languages. Xcode primarily supports Objective-C, C, C++, and other C languages like Objective-C++, and Swift. But if you're doing, say, God forbid, React Native and having to write some TypeScript or JavaScript, there's no support for that in Xcode. Or you're doing Flutter with Dart. You need to use another language that has the kind of tools that you want, because you can't do it in Xcode, at least easily. It might be that you're writing some website stuff and building a website with Publish, where you have CSS and HTML files that you need to edit. So you want an IDE that's built for those languages. You might want to just open a file. And we've all been there where you have a Swift file. I'm just going to quickly browse this, double-click, and then it takes 30 seconds to spin up Xcode and load the dependencies. And all you wanted to do was see what that file was doing. So there are some lighter weight IDEs out there that help you do this. You might be working on different platforms. So if you're writing code on Linux, There's no Xcode on Linux. If you're writing code on Windows, Swift code on Windows, there's no Xcode on Windows. So you need an IDE for those platforms. And Xcode does have its limitations. One of the really annoying things is its file view. You can't see hidden directories or files. So if I'm trying to edit my GitHub Actions file, I can't do that inside Xcode, and it drives me mad every single time. And also, Xcode is really, really big. I know they've made some improvements with Xcode 14 where you're not pulling down all of the SDKs, but it's still many, many gigabytes to download every time you want to update and download a new version of Swift. And you don't need to do that all the time. So there are a lot of things that actually go into an IDE that you might not expect. So the Swift project has a lot of moving parts. So to start with, there's the compiler that compiles your code. There's the package manager that manages all your dependencies and how to build them. There's Swift test for running your tests. There's LLDB for debugging and integrating with your symbols during runtime. There's SourceKit, which provides syntax highlighting and code completion. There's SourceKit LSP, which is the language server protocol, which hooks into SourceKit to allow you to show code completion in different IDEs. And hopefully one day Xcode will move over to that. So there's all these different moving parts. So if you want to use Swift in a different IDE, you have to integrate all of these different parts. And it is not easy. It is quite a lot of work. And there's a lot to go into it. Which brings us to Visual Studio Code. So VS Code is an open source IDE based off Visual Studio, but it doesn't look anything like it other than the name, written by Microsoft. So it's open source. You can go onto GitHub and view the source code. They get hundreds of GitHub issues every hour. It's honestly a nightmare trying to keep track when we've raised some issues in it. But it provides an open source IDE for working in pretty much any language that you want. It has a really good extension ecosystem, so you can download extensions for prettifying JSON or pulling and support for Rust, for instance. And it is really nice IDE. It's also multi-platform, so it works on Linux, it works on Windows, it works on macOS. So no matter what platform you're developing on, you can use it. And it supports lots and lots of languages. So if you're writing in any kind of language, there's a chance that there's an extension for it. So if you're doing HTML, or doing JavaScript, or you're doing Rust, or Dart, or Go, or any of these kind of new modern languages, or even the older ones, there's an extension that allows you to give you the same experience as you're writing Swift code in Xcode. And it has a great extension ecosystem, so as I mentioned. So if you want to put in a JSON file and format it in a particular way, there's probably an extension for that. If you want to trim down whitespace or minify files, there's an extension for that. So have a look, check out the marketplace, because there are some really great stuff, really great extensions on there. So earlier this year, back in July, the Swift Server Workgroup announced the Swift extension for Visual Studio Code. And this is a officially first-class supported by the SSWG at least, extension for Swift for writing Swift code and building Swift applications in Visual Studio Code. We've been working on it for quite a while, and it looks something like this, but don't worry about that because we're actually going to go into detail later. But it provides everything that you'd expect. It provides code completion, syntax highlighting, integration with the debugger, integration with testing, build options, and it is actually now at a point where it has pretty much parity with Xcode. So you can go to the Swift Server Marketplace, the Visual Studio Code Marketplace, and search for Swift. And it's up there. It's the one with all the 5 stars, thankfully. It's almost kind of taken over some of the community ones in terms of downloads. So go and check it out. And it's really easy to install as long as you've got Swift on your system. It just works. It configures everything for you, so you don't need to go and set up LLDB. You don't need to go and set up SourceKit. It's built to do all of that for you. So we actually launched it at the start of the year. Work began in December last year as a Christmas project by one of the original authors. And as I said, it provides everything. So you get syntax highlighting, code completion, test support, Swift package manager support. So if you want to update your packages, if you want to edit them, there's built-in support for that. Some of it is better than Xcode's, which I'll show you later. And the big one is remote development support. So Visual Studio Code has a extension for remote containers, and this allows you to basically reopen your project inside a Docker container to be able to test your code. So if you need to test your package on, say, 4 different versions of Swift, you can just reopen your project in that Docker container, and you're there with a full IDE running inside that Docker container on Swift 5.4 or for Swift 5.5 or Amazon Linux or Ubuntu Linux. And it makes it really easy to test all these different variations. So there are some caveats. The first is there's no Apple-only framework support. So if you're building stuff with UIKit or Swift UI or Core Animation or AV Foundation, it's not a great experience at the moment. And you can't build macOS or iOS apps yet. We are doing some work on it. The latest is that there is some support for pulling in the symbols for different frameworks. So I believe now if you kind of write the right incantation of compiler flags, you will get co-completion and syntax highlighting for private frameworks. But it is not officially supported yet, and things don't work exactly. But there's a really good discussion, GitHub discussion on the GitHub page for the repository for the extension, because it's completely open source. So go and check that out, and that shows you how to kind of get started working, and you can raise issues and see how it works. And the focus at the moment is on Swift packages and scripts. So if you're writing Swift scripts, we can invoke scripts really easily, and if you're writing Swift packages using Swift Package Manager, then it works. If you're using CocoaPods, if you're using an Xcode project with builds, tools and scripts and pre-build stuff, yeah, tough luck. And hopefully that will go the same way in Xcode one day, because it's a very old format that needs to die. But the focus is on Swift packages. So if you have a package.swift file with the top level, so you're writing a command line app, or a Swift package that you want to put into iOS projects, as Daniel showed, we can build it and we can run it. So I'm not going to spend all day talking at you. I'm actually going to do a live demo for you, because it's much more interesting for me as well as for you. So I have a project here. I'll just remove my little, I've lost my, there we go. So I have a project here. It's a Swift package, so I'm going to open it up in Visual Studio Code. And is that visible at the back? Yep, cool. So this is a Vapor app, unsurprisingly, because it's me, that defines, so you have a package.swift that defines a couple of targets, one executable target, some tests, and that's basically it. It's a very simple Vapor app with a couple of routes. So I can build and run this, just to make sure it's compiled. You can see I have all my package dependencies, just like you have in Xcode. You can see all the different versions. You get to see your file explorer to see all the different files. And I can view my tests. I can set breakpoints. I can run my tests. Excellent, it's rebuilding it for me, thank you. But this will basically build and run my tests. You can see you get all the same output as you do when you're building from Xcode. Sometimes it's even easier to see what's going on, because it's not hidden behind a thing. And let me run them as debug mode, which is the one annoying thing at the moment, is that tests are not run with a debugger by default. So this will compile my tests and then run them as you'd expect. It's doing something. Yeah. When I was trying this out again this morning, there was a very amusing bug where it said it could not import a module, Objective-C module, when it was doing import app. And then even when I rebuilt it, it was still showing that error, which means it's not Xcode who just likes to keep errors lying around. It is actually SourceKit. Let's try that again. Okay, cool, right. Okay, well, we'll go through to running them instead. Okay, so this starts up my app. So I've got basically a web server that I can test locally. So if I go into my client, I can go to /hello, and it hits my breakpoint. I can inspect the call stack. I can go to the debug console and print out the requests. You can see I get code completion from all the different things that are around. I even get the same errors. And you can see I get all the variables, so if you want to inspect them, it's the same as Xcode because it's the same debugger. It's LLDB under the hood. And then I can press play, and I can go back to my thing, and you can see I get my response back. So I'm going to create a new route to get the OS that I'm running on. So one of the really nice things about Visual Studio Code is Copilot, which is a GitHub project that will basically generate your code using AI. There's quite a bit of controversy around it at the moment, but it is kind of frighteningly cool. I find it really useful when working in languages I'm not fully versed in. So if I have to nip into, say, write some JavaScript or some Go or Rust, it really does help you out trying to find out what to go on. But you can see here it's suggesting that I need to basically return a string with the operating system version. I'm actually going to change that to it's the wrong way around. So you can see it's suggesting that I do return Linux because I'm inside Linux. Okay. And then return macOS because I'm on return macOS. It is kind of frighteningly worrying. So I'm going to rebuild that. And actually, I'm just going to put in a so I've got something to put a breakpoint on. So if I build and run that now, I can then go back to my REST client and go to the OS route, and you can see I hit my breakpoint, and because I'm on macOS, it's going to return macOS. Cool. Okay, so I'll stop that. So I'm going to reopen this inside my container. The Swift Server Workgroup maintain a Visual Studio Code remote container for Swift, which provides everything you need for setting up Swift. You have a .dev container file, which contains a doc file and your kind of configuration, and you can set your Swift version there basically, or you can hard code it in the Docker file as well. But this is all provided for you, so you essentially do dev container, add dev container configuration files, press enter, find Swift, press enter, it's done it for you. And then you reopen it inside the container. So if I now run this, this is now running inside a Docker container, running Swift 5.6, I think, because I haven't updated it. But it will rebuild it, but it still allows me to hook in and debug on a different OS, essentially, which in this case will be Linux, as we'll see, fingers crossed, when it prints out the OS. I did build this earlier, hoping it would be a bit quicker, but there we go. Okay, so you can see it's now, I've configured my application to say it has an open port. So you can see that it has a suggesting go to a port, but I'm going to ignore that and go to my REST client instead. And if I go to OS, you can see I've hit my breakpoint again. If I step over, this time I'm inside Linux because it's running inside a Docker container, and I can return Linux. If I send that request again, you can go to the debug console. You can still get your code completions. You still get to be able to breakpoints. You can still inspect all the variables and all the data that contains, just like you're running natively. And that's a really powerful feature if you're writing cross-platform code. Okay, so I'm going to go back to my... I've messed it up now. Let's go back to the container, see if it does it quickly. Because you can also run your tests on Linux as well. There we go. So when you're writing cross-platform code, it's important to note that when you're running on Apple platforms, such as iOS and macOS, you're running what I like to call legacy Foundation, because you're running the Objective-C version of Foundation. When you're running on Linux and Windows, you're using a pure Swift version of Objective-C. A pure Swift version of Foundation, which is the real language, and it's significantly faster. It has much less tech debt, but there are some slight differences because not everything's been ported over, because it doesn't need to interrupt with Objective-C. So running your tests on Linux is really important to make sure your code does work and does what you expect and doesn't throw errors. So you can see here, I have actually run my test now. You can see the full call stack to go through to my tests, and it's hit my breakpoint. So the tests do work, at least on Linux. And you get the output down below, saying one test has worked, and you have your test explorer where you can see your tests, etc. So if I get out of my container, okay, so one really nice thing about using the Swift for Visual Studio Code extension is editing packages. So in Daniel's talk, he opened a lot of local packages. And when you're creating an app with your code side by side, or even in the same package using kind of a monorepo, it works great. It's really good. But problems happen when you start to push your dependencies up to, say, GitHub. So if you have a package you're depending on, say, for instance, this case in Vapor, and you want to make some changes in Vapor because you've hit a bug or you want to add a new feature, to be able to do that on Xcode, you have to kind of pull down the project, you have to open a new workspace, you have to drag in your app into Xcode from the workspace. You then have to drag in Vapor as a dependency into the workspace for it then to be able to resolve it locally, to be able to make changes in your local directory. The Visual Studio Code extension makes this far easier because you can just click Use Local Version. It takes you to Finder thing where you can choose which package to replace it with. So I'm going to replace it with Vapor there. And this switches it out to an editing thing. So I can now open up my projects in Xcode by clicking Add to Workspace. Sorry, I can open my project in VSCode. And you can see here I have my Visual Studio Code project and also my Vapor project. So I can now open up something like Server Handler, which is where I was making some changes earlier, and do my editing here, build and run it. It will use my local version, which I can then commit and push. And then when you're finished, you can remove it from the workspace and then just revert to original version. And that will go back to GitHub, pull down the latest changes, and you're using your local version. And this is a far better experience than trying to do this on Xcode. And it will generate all your build targets for you, all your tests will come up as well, which I probably should have shown. But you can see all your tests for that, your dependencies as well, and all your build targets. So you don't need to configure build dependencies, you don't need to configure new schemes. It's set up all for you, as you'd expect with Xcode. Okay, so the final part of the demo, if I press the magic button here, is if I switch on to my iPad. So people have been clamoring for ages about wanting to be able to develop applications and projects on the iPad. And you can kind of do this with Swift Playgrounds. You don't get the full features. You don't get access to everything. But there is a better way. So because Visual Studio Code supports running inside Docker containers with the remote development containers, there's a new feature, or relatively new feature, called GitHub Codespaces. So I can go to my project. So this is the repo on GitHub. And I can create a code space for my project. Because it's being configured to work inside a dev container, it will also work inside Codespaces. So I can just open this in the browser. And this will launch an instance of Visual Studio Code on a server somewhere with the project, with all the extensions you define, including the Swift extension, with everything that you need to be able to run your project on your iPad. And this is running a full version of Visual Studio Code inside the browser for you to use. So I can open up my rich.swift. You can also configure your code space to have the same key mappings as Visual Studio Code. And I like to change my Visual Studio Code key mappings to match Xcode, so it's the same experience all the way through. So I can have the same key mappings for Xcode to say, run my project as Command R in the browser as I can on Xcode and inside Visual Studio Code. So I'm going to create my new routes here. Unfortunately, I don't get CodePilot to write it all for me this time, so I'm going to have to write it out manually. But you can see I get code completion as normal because it's the same thing essentially. So this is the same route, so I'm just going to build and run this, and this will compile my code on the remote server inside the Docker container, running inside Linux, and then expose it as a project for you to be able to connect to through the browser. Or if you have the plugins for, say, PAW, you can connect to it via PAW as well. And this allows you to work on an iPad using a full IDE with all the power that you'd expect from a proper IDE, including the debugger, including code completion and all this kind of stuff. And it gives you the same experience as if you're writing inside Xcode. So you can see here, this time I'm going to click Open in Browser. And this will connect back to my Docker container running inside Visual Studio Code, running inside a server somewhere on GitHub. And then I can go to my /os and see it says Hello Linux. If I go back, I can still put breakpoints in, refresh, and I have breakpoints inside a browser window that I can then print out everything you'd expect, and it all works exactly as it was running when running locally. So that was the Visual Studio Code extension. So to kind of recap, Visual Studio Code works across platforms and in the browser. So if you ever wanted to write Swift packages on your iPad, you can now do it. It's easy to try out different versions of Swift and different operating systems as well, which if you're writing cross-platform code is really important. And it makes it really easy to test your code on Linux as well, which when you're writing a web framework is really important because almost everyone deploys to Linux. So you must make sure it works on Linux. There's really good ecosystem support, so for things other than Swift as well, so check those out. And the kind of aim for the extension really is to be better than Xcode for developing Swift. We don't have to worry about supporting Objective-C, which makes our lives a lot easier. We don't have to worry about supporting applications really, and we can evolve quicker than Xcode can. One of the big problems with Xcode is that the Swift version is tied to the release of Xcode. So if there's a bug in the Swift compiler, for instance, you've got to wait until the next version of Xcode, which could be 6 months away. Whereas we can get a monthly patch release out for Linux and integrate it. And if there's problems inside the IDE, we can just ship them and release them as and when, rather than have to wait for the next version of Xcode to be released if there are problems. So this allows us to iterate quicker and hopefully provide a better experience. I would say we're pretty much there in terms of parity between Xcode and Visual Studio Code. There's still a few quirks, especially around viewing code for dependencies, but it's almost there. And I use Visual Studio Code about 50% of the time now when developing day-to-day. So some future aims that we want to look at are code coverage. So we're waiting for Visual Studio Code to release their new code coverage plugin, essentially. They're rewriting how code coverage works, so waiting for that until we can kind of hook into it. We want to support Windows properly. We're pretty much there, with the main issue being that the main developer or maintainers of the extension don't actually have a Windows box, so we can't really test it. So if you use Windows and you want to try it out, please do and create issues. And if you have an idea for things that you think would be really cool for the Swift extension, then get in touch. You can go to GitHub, find the extension. I will post a link on the slides later somewhere, if it's not in here already. And you can create issues and start discussions. Two special mentions. First is Stephen Van Impe. He was the original creator who wrote the package view before it got adopted by the Swift server workgroup. So this really wouldn't have happened without him. And then Adam Fowler, who is the main maintainer of this, he does all the work, and I get to come on stage and talk about it and take all the credit. And then finally, the Server-Side Swift conference. So we're back, like other conferences. We've had a 3-year break because of some disease or something. So we're back after 3 years. It's going to be in London. We've got the IMAX Theatre inside the Science Museum. We have Apple sponsoring, which is a very rare occurrence, and speakers from Apple and Amazon and Ubuntu and plenty of other really great speakers. So if you want to go to the website, there's a QR code there you can scan. There's a discount code for attendees of the conference. There's Do iOS Conf, it gives you 15% off tickets. And if you're interested, check it out, and it'd be great to see you there. Thank you.
Thanks for your talk, Tim, and about the conference that you're putting on. Highly recommended. I'm standing here with my dangerous box again. So do we have any questions? Okay, so people are not afraid. There you go.
Hi, thanks for the talk and thanks for the extension. It looks awesome.
Yes,
I'm going to check it out. Are there any plans for helping the bad Vim developers?
No, essentially. So the SourceKit LSP, which is the kind of underlying code that kind of hooks into SourceKit for code completion and syntax highlighting, all that stuff. Vim should work with that.
It works, yeah.
Because it's LSP. But all the other stuff around like tests and hooking into the debugger and package editing and stuff like that, that's all specific to VS Code. So we can't even port this to things like Atom or any other IDEs because it's very much hooking into all the APIs of VS Code.
And code completion for private frameworks, is that part of SourceKit or is that done in the...
That's part of SourceKit, yeah.
Okay,
so
awesome.
I believe it does work for Apple frameworks now if you basically tell it where to find the headers or the modules, and it will expose them. But there are some hacks you need to do to make it to search in that place in the first place.
Okay, thanks.
Anyone else? Yeah, one behind you.
About if for building apps and stuff, if you would use a CI for actual building, of course you still would have a lot of problems like debugging would need to be on a remote or things like that. Do you see that working somewhat or?
Long term, yes. If I look into my crystal ball, I can see that the Xcode project file is going to die, and at some point, all the work they've done to make applications for them to write, for you to be able to write applications in Swift Playgrounds with the kind of .app stuff for defining an iPad target and an iOS target, I suspect that will eventually make its way back into Swift Package Manager properly and open sourced, which will then allow you to define iOS apps using package.swift file. And as soon as you can basically build from the command line, we'll be able to build it in Visual Studio Code, because all we do is shell out to Swift build, essentially. So if that works, then there's no reason why we can't build apps.
But not currently in even hacking around with CI or doing
yeah,
building
so
somewhere
we
else.
can't really switch. So for you to be able to build an actual iOS app, you need to invoke Xcode build. And the way the extension works is that it has to invoke Swift build. And being able to change that switches out a lot of the low-level stuff that is not worth it for the extension.
Okay, yeah, thanks.
Anyone else?
I think that's it.
Cool, awesome.
Okay, thanks, Tim.